Hello friends, I am Vinay Rawal. I am from IIT Kanpur. I will teach you theory of automata course. This course is very interesting and this course will be helpful for almost all GATE aspirants because during the course I will discuss all previous year GATE questions. I will cover regular languages, context-free languages, context-sensitive languages, recursive languages and recursively enumerable languages in deep. We all know algorithm is the core field of computer science branch. Now I'll tell you why are we studying automata. Now algorithm is a set of instruction which is used to perform a certain task. Now the task can be anything, a square of a number or a cube of a number or factorial of a number, anything. So an algorithm is nothing but to compute a certain task, that is to it is a solution to compute a function, like I told you before, a square of a number or anything, any function. Now does algorithm exist for every problem? That is, my question is, given a computational problem P, any computational problem P, is there an algorithm to solve P? The answer is may or may not be. Means there exists some problems for which we don't have an algorithm, and I say you there exist infinite problems for which we don't have an algorithm. All these problems for which it is impossible to construct an algorithm is known as undecidable problems. Now, given any computational problem P, how do you detect whether the problem is decidable or undecidable? This question is very useful and it's very interesting. Suppose, consider an example. Suppose my thesis guide has given me some problem P to design an algorithm for P. If P is undecidable, then there is no need to research on it. Now you can think it is very useful question. Now this question can be solved by using membership problem. Now what does this membership problem? A membership problem is that given any element W which belongs to a universal set, whether this W is a member of a particular set X or not. Consider an example. Suppose I have a set of 4 integers 1, 2, 3 or 5, and I'll ask you whether 20, that is whether W, that is 20, belongs to set X or not. The answer is no. And if I'll give you 1, then 1 belongs to set X. The answer is yes. So membership problem is given any W which belongs to universal set, whether it is a member of set X or not. Now I have to teach you graph of a function. One more term, graph of a function. Graph of a function is a comma fa. All those terms a comma fa where a belongs to domain of a function. Here by mistake I have written f. For example, if a function is x square, if a function is used to compute the square of a number x, then the graph of a function x is all such pair 1 1, 2 4, 3 9, because the square of 2 is 4, the square of 3 is 9, the square of 4 is 16, the square of 5 is 25, and so on. So this is the graph of a function f set for a particular function x square. Similarly, we can write graph of a function set for x cube and all this and etc. Now membership problem for GF, that is graph of a function set, is given any random pair AB, whether it belongs to graph of a function set or not. Consider, suppose this is the graph of a function set for a function x cube. Its next pair is 4, 64. Similarly for 5 and so on. Now if I ask whether 2, 5 pair belongs to this set or not, the answer is no. How do you know? Because If we compute the cube of this 2, the answer is 8, and 8 is not equivalent to 5. So 2, 5 does not belongs to this set. Now if I will give you 4, 64, the answer is yes. This element belongs to this set because if we compute the cube of 4, its answer is 64, and 64 is equal to 64. So 4, 64 pair is a member of this graph of set of function f cube. So there is one theorem which says if we cannot able to answer the membership problem of GF for any function f, then that f is undecidable problem. That is, we cannot able to write an algorithm for that f. So membership problem is directly related to detect whether any function or computational problem is undecidable or not, or in other words, with the help of membership problem we can detect whether we can write an algorithm or construct an algorithm for any function or computational problem or not. Now we are interested only in sets which have strings as an element. Previously we have studied a set which has integers as an element. Now, but we can convert any set which have floats element or integers element into set which consists only of strings. How? Suppose consider this set. We can convert this set into this is a set which consists of integers as an element, pair of integers as an element. We can convert this set into set of strings. How? If we encode each integer element by some character and in each bracket also, then that set consists of strings as an element. So by using some encoding scheme we can convert all sets which is either integer sets or float sets into a set which consists of all strings as an element. So I conclude, but why are we studying automata? Automata is the main use of automata is to detect whether given any computational problem or any function, whether we can able to design an algorithm for that problem P or not, or there are some other use of automata also. Automata is heavily used in compilers. In compilers, automata is used in lexical analysis phase and syntax analysis phase, etc. Automata is also used in digital electronics also. With the help of automata, we can design many circuits, sequential as well as combinational circuits. Automata is heavily used in many subjects, many concepts or many areas. So we will study automata in next lecture in detail. Thank you. If you have any query, please comment and give me your valuable suggestions so that we can improve our video lectures. Thank you. Thank you for watching my video.